girls. Today we're going to look at Module 4, Lesson 22. We've been looking at writing expressions and using those expressions to solve equations. We've been using addition, subtraction, multiplication, and division. Today we're going to look at expressions that have exponents in it. So before we start applying the exponents, let's just review what the exponents mean. We're going to start actually in the middle of the lesson on example 2. So please turn to 102, 103. You should have today's date on top of the page. The bottom of page 102. An example of what exponents are. One example from real world would be in a science class. I think this is 8th grade, you'll learn more about this. You've already learned about bacteria in 6th grade and single-celled organisms. So bacteria are microscopic one-celled organisms that reproduce in a couple of different ways. One of which is called binary fission. In binary fission, bi meaning two, like a bicycle, binary fission, a bacterium increases its size until it is large enough to split into two parts that are identical. These two grow until they are both large enough to split into two individual bacteria. This continues as long as growing conditions are favorable. So here's our first generation. We have one. Then it's split off into two. So our first generation created two bacteria, so that would be written as an exponent 2 to the first power. Now here is our second generation. Each one of those split into two. So our second generation was 2 times 2. 2 times 2 can be written as 2 squared, or 2 to the second power. This is the table on top of page 103. Please don't go ahead. So now let's take a look at the third generation. So here we have 3. So 2 times 2 times 2 at third generation, so 2 to the third power is 8, and so on. So this is just an example of what exponents are. 2 times 2 times 2 is 2 to the third power, and so on. Another example, if you've ever seen a spider plant, how the spider plant will have the stem coming out, and then more leaves, and then out of one of those leaves, some people don't like having spider plants because they'll just keep growing and growing and growing, and they're constantly clipping them down and trimming them. That's another example of exponents, okay, how they keep expanding. I like this real-world example of using exponents in an equation. Okay, so let's take a look at this equation. The last one didn't have an equation. It was just a better example of what exponents are. Take a peek at the top of page 104. Okay? If you remember back, I don't know, a quiz or two ago, we looked at area of a square. So S was our size. So we know that area equals length times width. Area is side times side. So area was side squared, because S times S is side squared. Any questions on that? No. No. Suppose we change that to volume. Just move this over. So we have length, width, and height. So we know that we always write the formula first, formula to answer. So because this is a square, or a cube, or a square prism, whichever word you want to call it, length times width times height, so side times side times side. Because all the sides are equal, I can use the same variable. So volume equals side cubed. And then when I know what S is, I can replace it and find the exact area or volume. Any questions on what I just did? No. Okay, well now suppose it's not a square. Okay? I'll leave this here. Oh. Okay. Now suppose we have a rectangular prism, meaning the sides are different lengths. So here we have a box that has a width of W. So here's my width W. It's telling me that the width, the height, and the length is in a ratio of 1 to 2 to 3. We remember from way back in our ratio unit that order matters. So that means width to height to length is 1 to 2 to 3. You might want to write that on top of page 104. All of this is in your notes, but to be honest, I don't like the way that this is worded and it's explained. So God bless you. If you write this little key, God bless you, off to the side, it explains what it's trying to tell you there. So if my width is 1 and my height is 2 of those, my smart boy, that ghost is acting up again today. So anyway, so if my width is 1, right there, my width is W. But my height is 2 of them. So my height is 2W. My length is 3 times that, so my length is 3W. So now if I want to find the volume of that rectangular prism, what's my first step? I have to write the formula. So here I write my formula. Volume equals length times width times height. That's in your notes. Circle it as a little reminder to always write the formula first. Now, what is my length? My length is 3W. My width is W. My height is 2W. So I replace the letters in my formula with the measurements of the sides. Do I know what the width is? No. So for now, I'm just using my variable W. So far, so good? So I remember from a couple lessons ago that I could take my 3W times W times 2W, expand it, and use the commutative property to rearrange them. So here I have my coefficients together, 3 times 2, and then all my variables together, W times W times W. Does everybody see what we did in that step? So then I can combine my like terms. 3 times 2 is, and W times W times W is W cubed. I don't like that they don't have the unit there. So volume is always units cubed. So if you want to add the label to your answer, James, that would be great. Add the label to your answer. Units cubed. All right, so right now we have to leave the volume as a term with the coefficient and the variable because we don't know what the width is. But suppose we do know what the width is. So if the width was 1, we would take our formula, volume equals 6W cubed. Volume equals 6. Our width is 1 cubed. V equals 6. What's 1 times 1 times 1? So volume equals 6 units cubed. Oh, so here they're telling us it's centimeters. So here it's labeled, our unit is labeled in the heading of our chart. So now let's try it when the width is 2. 2 centimeters cubed. I follow my PEMDAS rules and do one step at a time. What is 2 cubed? 8. 6 times 8 is? And I always label my answer. suppose our width was 3. Try to solve that one. So 6 times what's 3 cubed? And then what was your answer? Yeah, I keep writing units. Yeah, centimeters cubed. Now, there's another way we could have done this. Suppose we did it this way. Volume equals length times width times height. Volume equals, what's the length? 2W. Oh, 3W. Length was 3W. The width was W. And the height was 2W. Right? Yes? Does everybody see where those came from?
Yes.
Before we combine them, volume equals length times width times height. Volume equals, my length is 3W, my width is W, my height is 2W. My width is now 4. So I could replace it this way. 3 times 4 times 4, 2 times 4. So volume equals 12 times 4 times 2 times 4. 12 times 4 times 8. 48 times 8. And then volume equals 384 centimeters cubed. So you could solve that both ways. We used our formula with the exponent in it, or you can go back to length times width times height and replace that. So if we don't know what the width is, since volume is length times width times height, so volume equals length is 3W times width times 2W, and that equals 6W cubed centimeters cubed. Remember, we have to label our answers. I wrote the equation in that bottom box because I didn't have room on the bottom of my page.